Let us analyze isothermal process in detail. As we already discussed, isothermal process is the one in which the temperature of gas remains constant. So in this situation, if say a gaseous state is P1, V1, T1, which is initial, and it is changed to a final state such that the gas temperature remains constant, so pressure and volume will change, but temperature remains same. Here we can write delta T is 0 as well as dt is equals to 0. And by mole conservation and relating thermodynamic coordinates, we can write P1 V1 is equals to P2 V2 as temperature remains same. So this is the relation which is Boyle's law, which is used to relate the thermodynamic coordinates. And if we just analyze using first law of thermodynamics, we can state dq is equals to du plus dw. Here as temperature is not changing, it is constant, so we can write in this situation du is equals to 0 as u is constant because internal energy depends on temperature. So as temperature is constant, u is also constant. So the term of change in internal energy will vanish here, and we can say whatever amount of heat is supplied is used in doing work. So directly we can write about thermodynamic parameters of the isothermal process as change in internal energy in an isothermal process can always be written as 0. And we can simply write about heat supplied is always equals to work done by gas, and it can be calculated as Q is equal to W, which is integration of P dV from V1 to V2. And by gas law here, pressure can be written as integration of nRT by V dV from V1 to V2, where this nRT is a constant can be taken out of the sign of integration, and 1 by VTV will be integrated as nRT ln of V. Limits will substitute from V1 to V2, which can be written as nRT ln of V2 by V1, which is the amount of heat supplied or work done by the gas in a given isothermal process. So always remember that this is the expression we use for heat supplied and work done. And in an isothermal process, the total amount of heat supplied is always 0. As just now we have discussed that heat supplied or work done in isothermal process can be written as nRT ln of V2 by V1. And as we have studied about isothermal process, we can apply Boyle's law as P1 V1 as P2 V2. Here V2 by V1 can also be written as P1 by P2. This can also be substituted in calculation for heat supplied or work done as nRT ln of P1 by P2 if we are given with pressure rather than volume, and also we can use it. In sequence, we can also discuss ID for isothermal process. For indicator diagram, we can state as temperature is constant, or we can write delta T is 0 and dt is also equal to 0. So here we can write in this situation the product of pressure and volume is also constant. So we can write pressure is inversely proportional to V, or P is equal to some constant by volume. So if we plot the PV curve for a given isothermal process, this will be a rectangular hyperbola because it is an inverse proportionality curve. We plot the simple curve for isothermal process and pressure and volume. The curve will look like a symmetrical curve for x and y axis both. If this is the initial state with pressure volume P1 V1 and it is expanded to state 2 from initial P1 V1 to P2 V2. We can see the expansion is there, so work done will be this much area, and corresponding to this, here we can write the temperature of gas is constant in this situation. This area is given by these expressions. if the temperature is increased, we can see that the area will increase, so curve will also lifted up, or we can say it will move away from origin because this constant is actually nRT. So it depends on temperature. So for various temperatures, we can draw several isothermal processes which are drawn like this, and corresponding to all these thermodynamic processes which are all isothermal, you can say temperature is changing, the curve will be shifted parallelly away from origin. So there's a temperature T1, there's a temperature T2, there's a temperature T3, then T3 is more than T2 is more than T1. And this family of curves are called isotherms. The family of several isothermal curves plotted on a single PV diagram are termed as isotherm. And there's a single isotherm which is used to plot one isothermal process on indicator diagram. If an indicator diagram is plotted like this, between pressure and volume axis, say there is an initial state 1 and a final state 2, and both these states are lying on same isothermal curve, or we can say the temperature at a state 1 and temperature at a state 2 are equal, then we can state these two states must lie on an isothermal curve. Now, if in this situation the gaseous state is changed from 1 to 2 corresponding to this path 1. So we can say in path 1 and going from state 1 to state 2, qualitatively we can state as the curve is going above isothermal curve and coming back to 2. Then in this process we can state first temperature is increasing and then it is decreasing. If we talk about another isothermal curve, say it is path 2, then in part 2 we can state first temperature decreases then increases. So there are so many interpretations we can make if we are aware about the isothermal family of curves, and in either of these 1 and 2 we can write delta T is 0 but dt is non-zero. So these are non-isothermal processes, we can say is 1 and 2 are non-isothermal processes, as here dt is non-zero. So in path 1 we can say temperature first increases then decreases because it is coming back to same temperature. In part 2 as it is going down, so we can say T first decreases then increases. So such qualitative relations also are quite important in understanding different kind of problems related to isothermal and non-isothermal processes.